Welcome to week 22 of maintenance for Statistics 1. Once again, we're working through different aspects of the curriculum that we've already covered in school, and the first section we're looking at is, of course, representation of data. We've got a table here showing the mean and the standard deviation of the weights of some turkeys and some geese, and we're going to find the mean weight of the 27 birds. Okay, so we're adding these two together here. So to find the mean, you're going to take the mean of the turkeys and multiply them by how many you've got. So there's 9 turkeys, and that gives you the total weight of the turkeys. Then you're going to add to this the mean weight of the geese, multiplied by the number of geese that you have. That will give you the total weight of the geese. And then you're going to divide that by 27. And so this should give you the mean weight of all of the birds, and I got 5.83 recurring kilograms. The weights of the individual turkeys are denoted by xt kg, and the weights of the individual geese by xg kg. By first finding the sum of x squared t and the sum of x squared g, find the standard deviation of the weights of all 27 birds. Okay, so first of all, we're going to find the sum of x squared t, and we do that by popping it over the number of turkeys that we have, and then subtracting the mean weight of the turkeys, and we happen to know that that is equal to our standard deviation squared. Okay, we're just using the variance formula here, and so we can just rearrange that, and then we will get sum of x squared t. And when you rearrange that, I was getting about 472.6125. And then I'm going to do exactly the same thing with sum of x squared g, and that's going to be over my 18 birds. Subtract I should have had my mean squared up there. Subtract my mean for the geese squared, and that should equal my standard deviation squared to give me my variance. And when I do a little bit of rearrangement here, I was getting that the sum of x squared g is approximately, is 503.3088. Now that we have this data, we can work out the standard deviation. So we know that variance is equal to the sum of x squared g plus the sum of x squared t all over the 27 birds that we have. Subtract the mean squared, which of the mean of both birds squared, which we've already got from previously. And this will give us, so we're going to chuck in those values, what is it, 472.6125 plus 503.3088, divide by that 27, minus the 5.83 squared, and this gave me 2.117, and then therefore the standard deviation is the square root of that. So I'm going to square root 2.117, which is equal to 1.46 to 3 significant figures. Okay, so that's our first question done. Done and dusted. Discrete random variables. Blah, 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 blah. Okay, so probability. 2 independent values of x are chosen at random. The random variable y takes the value 0 if the two values of x are the same. Otherwise, the value of y is the larger value of x minus the smaller value. I'm going to draw up a probability distribution table. Okay, so what are the different values that we can get here? Okay, well obviously you can get 0 if the numbers are the same. So, y. Now, the other option, if you got 4 and 2, you would get 2. If you got 6 and 4, you'd get 2. If you got 6 and 2, you'd get 4. So I think those are the only options you can get for this variable. Okay. Now, the probability that y is equal to a particular value of y, this is what we've got to figure out here. Okay. So, so if you get 2 and 2, that gives us a value of 0. If we get 2 and 4, that gives us a value of 2. If we get 2 and 6, that gives us a value of 4. If we get 4 and 6, maybe we'll do 4 first, 4 and 4. That gives us a value of 0. 4 and 6, and that gives us a value of 2. And then 6 and 6 gives us a value of 0. Now I've got to work out the different ways of doing it. So for 2 and 2, well, let's look at that. 2 and 2 is obviously 0.5 times 0.5. So it's 0.5 squared. And 4 and 4 is 0.4 squared. And 6 and 6 is 0.1 squared. So if we add these ones together, oops, what are you doing? Waking me up. There we go. So if we add this one, these ones are all zeros because they're the same. So we add them all together, and this will be a probability that we're going to stick in here. So 0.5 squared plus 0.4 squared plus 0.1 squared. I'm getting 21 over 50 or 0.42. Now, here's a way of getting 2. Now, hopefully you can see there's two ways of doing this. We get 4, 2, or 2, 4. So it's going to be 2 times, and then 0.5 times 0.4. The other way we can get a score of 2 is if we have a 4 and a 6. Now, there's two ways. We can get 6 and 4 or 4 and 6. So two ways of doing this. Getting a 4 would be a 0.4 chance, and getting a 6 is a 0.1 chance. So now we're going to think about these. What score does this give us? So 2 times 0.5 times 0.4 plus 2 times 0.4 times 0.1. And I'm getting 12 over 25 or 0.48. Whoops. Yep. Okay, so this is 0.48. Now the last one here, there's two ways of getting a 2 then a 6. And it's 0.5 for the 2 and 0.1 for the 6. And so we got 2 times 0.5 times 0.1, and this is giving me 1/10 or 0.1. And you can see that they will add up to 1 probability, which is what we want. Oops, should have a bracket there. Okay, so EX is equal to 0 times 0.42 plus 2 times 0.48 plus 4 times 0.1 equals, and when we add these all up, I was getting 1.36 before. Okay. Probability. So Jason is throwing 2 fair dice. Okay, good. Event A. So event A, one of the numbers obtained is divisible by 3, and the other number is not. And then we've got event B. The product of the two numbers obtained is even. Are they independent? Okay, so we need to remember, how do we tell if two things are independent? So that's one thing that we need to do. So the test for independence is this. If independent, the probability of A intersection B equals the probability of A times probability of B. Now, I'm going to drop a little table over here to to help. So we've got our 2 dice. 1, 2, 3, 4, 5, 6, and we'll go down. 1, 2, 3, 4, 5, 6. And I'm thinking about, I'll do B first. So this is for item B. The product of the two numbers is even. So where do we get even? 1 times 1? No. So we get 1 here. 2 times 1. 4 times 1. 6 times 1. And then, when we're timesing by an even number, of course, all of those are going to be even. And then we'll see when we're timesing by the odd number again, we've got this scenario. And then when we times by the even number, all of them, odd number, and then the even number. Okay, you can see, hopefully, what I'm doing here. Now, what about the next one? So that's B, and then we'll do A. This will be A. So A, I'll use the highlighter. Okay, so for A, one of the numbers obtained is divisible by 3. Okay, so one of the numbers obtained is divisible by 3, and the other is not. Okay, so I guess if you get a 3 and a 1, so this one here, if you get a 3 and a 2, if you get a 3 and a 4, and a 3 and a 5, so that way. And I guess if you go 6 and you get a 1, 6 and you get a 2, not in a 3, 6 and you get a 4, and 6 and you get a 5. And I guess if we get a 3, if we get a 3 this way, I guess we can go there, 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 and I guess we can go 6 and a 1, 6 and 2, 6 and a 4, 6 and a 5. So I think those ones there. Okay, so that's one way of thinking about it. All right, now what's the probability of A? The probability of A is equal to, well, you can count up all of one way. You can count, I did it a different way before, but I guess if I just look at all my pink squares, 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got 16 out of 36, and that's 4/9, which is what I got before when I did it just mathematically. So 4/9, and the probability of B is equal to, now we're looking for the ticks. So what have we got? 3, 6, 9, 12, 15, 16, sorry, 15, what is that, 27? I think it's 27 out of 36. So I guess we can simplify that down to 3/4. And now we can do the probability of A intersection B. And that is all the ones where we've got both of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 out of 36. And that gives us 1/3. Now, let's have a look at the statement here. If they're independent, the probability of A intersection B should be equal to the probability of A times B. The probability of A times B is equal to 12 over 36, which is 1/3. Therefore, the events are independent. Okay. Are they mutually exclusive? No, because the probability of A intersection B does not equal 0, right? In other words, we can have A happening at the same time as B. Alrighty then, moving on to permutations and combinations. How many different numbers can be made by arranging all 9 digits of the number if there are no restrictions? Okay, that's nice and easy. So 1, 2, 3, 4, 5, 6, 7, 8, so it's 9 digits, 9 factorial, but then we've got a double up of 2's, so 2 factorial, and we've got a double up of 7's, times 2 factorial, and we've got a triple up of, is that a word? Triple up? I don't know. So we're going to do divided by 3 factorial there. And when I chuck this into the calculator, I'm getting 15,120. What if the number made is an even number? So to make an even number, you've got 1, 2, 3, 4, 5, 6, 7, 8. And you can have why don't we think about ending with odd numbers and then taking it away, right? I think that's easier because you notice that there is 2 different odds, okay? So you can either go 3 or 7 here. Whoops, not 3, 7, 3 or 7. Okay, so we'll find ways of making odd numbers and then subtract from even. So ending in 3, what happens? Well, if it ends in 3, you've got 8 factorial for the 8 other numbers. And if it ends in 3, you're going to have, let's have a look at our numbers here, 2, 2, 6, 7, 7, 8, 8, 8, and then ends in 3. So that's what we have. So you're going to have 2 factorial for the double up of the 2's, 2 factorial for the double up of the 7's, and 3 factorial for the double up of the 8's. Okay, so easy peasy, that one. And that's equal to 1680. Now, end in 7. Now, if you end in 7, what do we get? Let's toss that out here. 3 and then 7. Okay, now if we end in 7, there are... I guess we go 8 factorial ways, and so we're looking at these guys here. There's a triple up of the 8's and a double up of the 2's. So should be 8 factorial divided by what's that? 3 factorial and 2 factorial, so 6, 6, 12, 3360. Okay, and now we're just going to go, therefore, even equals the total number of ways, which we found is here, 120, subtract all of the odd ways, odd numbers, and that will give us the total number of even ways. So sometimes the easiest way of solving a question is to find out what you aren't asked to find out, like this one, finding the odds to find the evens. Okay, Sandra wishes to buy some applications. Oh, that sounds very fancy. Applications, apps for her smartphone, but she only has enough money for 5 apps in total. Okay. There are 3 train apps. Train apps. Is it like training? Or is it like getting the train to uni or something? I don't know. 6 social network apps and 14 game apps available. Sandra wants to have at least one of each type of app. Okay. Find the number of possible selections she can choose. Right. Well, train. Social media, social network, games. Okay, fine. Here we go. So she has to have one of each. So she could go 1, 1, and she's got to have a total of 5. So 1, 1, 3. 1, 3, 1. And 3, 1, 1. So that's one way of doing it, I guess. Then she could go to 2, 2, 1. 2, 1, 2. And 1, 2, 2. And I actually think that's it. So now we've got to work out each of these different ways. So the first one, there's 3 train apps. So she's going to go 3, choose 1. Then she's going to get the social network app. So that's 6, choose 1. Times 14 games, choose 3 of them. Now that gives me a 6, 5, 5, 2. Then the next one we're going 3, choose 1, which is just 3. Then we've got our 6 social network apps, so 6, choose 3, and then there's 14 games, he's choosing 1, so it's just 14, choose 1, or 14. Now that happens to be 840, I think. Now, the next one, it's 3, choose 3. Well, that's just 1, isn't it? She's choosing all of them. And then she's choosing 1 of the social network apps, so there's 6 of them, so 6 chances there. And then she's choosing 1 of the games apps, and so that's 14 times there, because she's got to choose 1 out of the 14, so 14 options. And that gives me 84, I think. 64, yep, that's right. Then the next one, out of the 3 train apps, she's choosing 2, so 3, choose 2. Then she chooses 2 social network apps out of the 6, so that's 6, choose 2. Then she chooses 1 game out of the 14, so that's times 14. And that gives us 630, I think. The next one was 2 train apps, so 3, choose 2. Times, and she chooses 1 of the 6 social networking ones, so that's 6. And then she chooses 2 of the games, so that's 14, choose 2. So that'll ramp it up a bit. 1638. And then the next one is 1 of the train apps, so it's out of 3, so 3. And then out of the social network she goes 2, so that's 6, choose 2. And then finally she chooses 2 of the games, so that's 14, choose 2 again. And that gives us 4,095, I think. Well, that's what I got before. Now I'm going to sum all of this, and my total is 13839, or 13,839. Okie dokie. Last question. In a certain country, 68% of households have a printer. Find the probability that in a random sample of 8 households, 5, 6, or 7 households have a printer. Okay, so this is just the typical binomial stuff again. So we're going to go 8, choose 5 households, and then the chance that 5 have them is 0.68 times to the power of 5, and then you've got to times that by the probability of not having them, which is 0.32 to the power of 3 for the other 3 households. And then we've got to add in when we've got 6 households. So that's 8, choose 6 households have the printer at 0.68 times to the power of 6, and then 0.32 not having a printer to the power of 2, plus finally 8, choose 7, and this will be times 0.68 for probability of having it to the power of 7, because 7 households, times 0.32 to the power of 1, because 1 household out of the 8 doesn't. We add all of that together. We're going to do it on our calculator. 0.722 is the answer that I'm getting for this. Well, I hope that makes sense. I hope these are being helpful to you in consolidating your skills. Let me know if there's any errors or problems or things you don't understand, and I'm happy to help. Take care. God bless.